All right, everybody, we're going to get started. Welcome to Hello World. I know it's really nice outside, so you're sacrificing one of your early spring Saturday afternoons to be here and learn to code, which is really cool. So thank you for being here. Just a quick note on parking. A lot of you kind of trickling in here. You found, obviously, there's not a huge parking lot out front, so a lot of it's street parking. There is free parking on Bayard over here, unmetered parking. There's metered parking up and down Delmar, plenty of that. Euclid is metered over on this side. And then the next street up, I forget the name of it, it's also unmetered. So feel free to park. What was it again? Enright. So Enright is also, it's back by the fire station back there, is also unmetered. One thing to note is the lot just on the other side of the fence from our lot here is not ours. It's actually the housing building across the street. It's theirs. So if you do park in that lot across the fence, you may get towed. We haven't had anybody get towed yet, but it's also not ours, and they are able to do that. So that's your own risk. So my name is Chris Bay. I'm going to be teaching the class. This is a 4-session class going over the next 4 Saturdays. So we're going to do a little bit of housekeeping to get started. And first off, I'm going to introduce Crystal Martin, who works here at LaunchCode, and is going to say just a little bit about what this program is intended to be, what LaunchCode does as a whole, and a few other things.
Good morning. It's not morning, actually, anymore. Happy Saturday afternoon. I'm Crystal Martin. I'm the Education and Community Engagement Manager here at LaunchCode, and I also direct the Coder Girl Meetup. So this class is really just designed for you to get an introduction to programming. So I like to call it kind of like dipping your paw in the water to see if you like coding, and then CS50 is kind of like throwing yourself into the water and learning how to swim. So this gives you a really good idea of, do I like this? Is it interesting to me? So you're not going to walk away from this class being like, I'm writing software and websites, but you'll know enough to make an informed decision about what your next step is going to be. And I'm here to help you to do that. So I'm the person basically that you're going to meet at the beginning of your LaunchCode process, depending on what you learn and what you want to do. So I'm the person who's like, okay, here you are, you know these different things, here is what you need to learn to be able to get to where you want to go. Let's get your job ready. Let's get you a job. So to give you a little bit of background on what LaunchCode does, we're a nonprofit organization that helps people get jobs in tech. And we basically convince employers here in St. Louis that people don't have to have computer science degrees to be excellent programmers. They just need to have some heart, will to learn, work really hard, and the ability to be coachable, and they can actually learn on the job in an apprenticeship, and then become that developer that company wants. And so we partner with over 300 companies here in St. Louis, and nationally we have a hub in Miami, we have a hub in Rhode Island and Kansas City, and we're actually working on national placements too. So say you want to go on an adventure to another city, we can also help you secure employment there too. So the world of coding is your oyster with LaunchCode. Like I said, I'll be the person who will correspond with you about your interests and the class. And so if you have questions about enrollment or, you know, what you're learning or what your next steps are, I'll be the person who talks to you about that. So I'm Crystal at launchcode.org if you have any questions. If you want to stop by Coder Girl, it's on Wednesdays right here from 6 to 8. It is designed for women but open to everyone, so don't feel weird about being a dude at Coder Girl. We have mentors and women, mentors and participants who are men. So that's it. If anyone has any questions for me, I'd be happy to answer them. I'm jittery because I just drank a bunch of coffee. Sorry. It's like, I'm usually not this crazy. I'm kind of crazy. But anyway, if anyone has any questions, feel free to stop me. I'll be here till the end of the class. Thanks. Do I need to?
Sure.
Okay.
So as you all know, you're here. You know this class is free, right? And this is a cool thing that's made possible by Wells Fargo Advisors. They provided the funding for us to do this class 5 times. We've already done it once. We did it back in November. It was really great. And we're going to do it 3 more times after this iteration, once a quarter. And so that's possible because it's supported by Wells Fargo. So just to introduce them to you, Scott Wells, who's the Director of Innovation at Wells Fargo, is going to say a few words about their involvement in the program and what they're interested in.
Thanks, Chris, and congratulations to every one of you. It is really exciting for Wells Fargo to be a part of this program. One of the things that's core to our mission is we want to help people to achieve their dreams, and we certainly understand that finance is a part of that, and having the money to be able to do what you want to do in your life is important, but it's not everything. It's also important that you've got the skills and the capabilities to be able to do those things, and that's why we've started this partnership with LaunchCode to help them help you to achieve that part of your dream. So it's really exciting for us to be here today as a part of this. Congratulations to you for taking this first step to explore what might be a great future for you. And we're happy to be here on this first step of the journey with you and wish you all the best of luck. And thank you very much for giving us the opportunity to be a part of it. Thank you.
Thanks, Chris. Okay. All right, so I introduced myself a little bit, but just to say a little bit more, I'm Chris Bay, and in addition to teaching this class, usually what I do at LaunchCode is something else, which is to run this building that you're in. It's called the Mentor Center. We opened it back in October. The building was made possible for us to be in by the state of Missouri. It's still owned by the state of Missouri, so we came in and did all the rehab work and turned it into this great community education facility. So it's my job to make sure that this building runs, that all the programs that happen, including Hello World and Coder Girl and CS50, and all the meetups that we host, the youth classes that you might have seen if you were in here early. There's some kids back in the classroom learning this morning, to make sure that those all happen and that they're serving the community and that this space is able to support St. Louis, north, south, east, west, black, white, brown, whatever. Everybody that wants to code should have the opportunity to learn how to code through this facility. So that's really the goal of this space, and that's why you're here, because Hello World is a really great first step to doing that, and it's very accessible and makes coding accessible to people who might not have had that opportunity otherwise. So if you're interested in anything else about any of the programs we do in St. Louis, in addition to Crystal, I'm also a good resource for that. Or if you're interested in about what else goes on here at the Mentor Center, I'm also going to be able to answer those questions for you. So just some quick housekeeping on the space. Restrooms and water fountain are up front if you haven't already found them. The rear area, this back door back here, is staff and mentors only, so please refrain from going back there. It's pretty attractive. I know there's like a really hip kitchen back there. That's a joke. It's got like furniture from 1970. But please use the front of the building. If you're eating or drinking, please make sure to clean up after yourself. So we have about 500 people in this space. Most people are coming straight from work or straight from something else. We understand you got to get some calories in, and that's cool. But there's a lot of folks coming through here and want to keep the space clean and nice for everybody. And finally, the space is open during the week. Our offices are here. The LaunchCode staff in St. Louis all work in that room in the back. So we are here and we are open, and during the day, this space is available for you to use. So if you have some time off, if you're off on Tuesdays and just want to come by and work, you can come by and work. There's a lot of people that'll just be hanging out, people that are working on CS50 stuff, whatever. This is kind of like a library for coding. So feel free to come by and use this space throughout the week as well. And finally, the Mentor Center, everything that we're doing here in this facility is on our website at launchcode.org/mentor-center, including this class, CS50, all that information. There's also a calendar up there that has when mentors are available to help. So there are people that volunteer their time to just come in and sit and just sort of be tutors for the programs that we run and to just ask whatever questions you may have about learning to code. So to find out, if you want to stop by when a mentor is available, go to that website and you'll be able to find out those times as well. Okay. Cool. So now we're going to get into the class. Any questions about Hello World or anything we've said so far? You guys hear me okay in the back? Is the volume good? Good? All right. So this is Hello World, an introduction to programming, and we're going to learn where that title comes from in just a few minutes. There's a very specific reference there in the Hello World. By the end of this course, what will you be able to do? This is only 4 sessions. We're going to have some homework. We're going to have some Monday night working sessions that are optional. So, but at the end of the day, you're not putting that many hours into learning how to code. We estimate that if you're starting from scratch, it can take anywhere from 300 to 500 hours to get to the point where you can get a job as a programmer in tech, right? We're not going to get that 300 to 500 hours in this class. So what are we going to get out of it? You're going to learn how to think like a programmer. There's a very kind of specific set of tools and thought processes that programmers need to have. It's not about knowing this language or that language or every sort of thing under the sky. It's about knowing how to solve problems and knowing how to think logically and critically. And so you're going to learn some of those skills in this class. You're going to understand fundamental concepts that every programmer should know. So there are some fundamental things that no matter what kind of tech programming job you want to get, if that is your goal, there are some things that everybody has to understand, and so we're going to introduce those in this class as well. And we are going to write some simple programs, and after we do that, you're going to know where to go to keep learning if you are interested in continuing to learn how to code. So one of the things we're going to do, and I'll talk more about this in the coming weeks, is this is only a 4-week class, but after the class ends, we're going to have Monday night meetups for just the general public, including people that are wanting to continue to learn after this class. And so we'll have things and learning tracks for you to keep working on, somewhat independently, but with mentor support after this class as well. So there will be built-in things to help you keep working. So Crystal mentioned CS50, so I want to kind of put this in a little bit of context and explain how this class fits into this vision of what CS50 is. CS50 is a class that is taught by Harvard on their campus. It's their intro to computer science. It's one of the most popular classes on campus. In fact, they just exported it to Yale. It's so popular that Yale wants the class too. It's being taught in high schools now at the AP level. It's a very, very good class. It's very, very hard, but it's very effective at getting people from zero to employable or getting all the base skills they need in a short period of time. It has just the right amount of stuff, and it teaches it in a really fun and engaging way that gets people those skills. The thing about CS50, though, is if you've never coded before at all, or maybe you did and it's been like 10 or 15 years and you kind of forgot everything, it can be really, really intimidating to start out with. So we did CS50 a few times in different formats, and what we found is that people that had a little bit of experience, maybe they had taken some Code Academy classes online, they had done some self-guided learning modules online, they just had just that little bit of exposure to code, they were able to start that much faster in CS50 and hit the ground running. And the people that had zero experience or had that experience a long time ago were really struggling for the first 2 or 3 weeks, and then all of a sudden they were behind everybody else and they just never really caught up, right? So this class is meant to give you that exposure, that base level intro exposure, just so if you do go into CS50, one of the goals is if you do go into CS50, you're at par with people that might have coded before. The other goal, as Crystal mentioned, is just to give you a chance to decide if this is something you want to do, right? It's a big investment. CS50 as a class is 16 weeks. The class meets for 6 hours a week in person, but we tell people that they should expect to work on it 15 to 20 hours a week. It's free, but if you've got a job, that's a lot of time. If you've got kids, family, whatever, that's a lot of time. So to decide to invest in CS50 is a big deal. So this class will help you decide if you want to invest in this. And CS50 isn't the only place you can go to learn the skills you need to become a professional programmer. There are a lot of other ways, but this is the most effective course we've found. It's the thing that we invest our time and energy into, making available to people here in St. Louis and in other cities as well. So we do CS50 not only in St. Louis twice a year, but also in Miami, and it's about to start in Kansas City and Rhode Island. So we do it in every city that we exist in, we run. We partner with local educational institutions, WashU, UMKC, St. Louis Community College, University of Rhode Island, to help bring those educators into the space and teach the community these skills. So that's kind of how Hello World fits into CS50. It's kind of a stepping stone. Hold on. So now we have a quick, this is just a quick, fun video that talks about coding as a skill and the importance of coding. There you go. There's some good reasons to learn to code. So let's jump into, by the way, I'm just going to kind of run through this lecture. At the end, we'll talk about how the class is going to work in terms of assignments and where things are, but we're just going to keep going on this kind of idealistic, idea-based, concept-based track, and then take care of business towards the end. So first is, what is computer science? So Intro to Computer Science is the name of that Harvard class we talked about. What is that science of computing, right? It involves a lot of things. It involves mathematics. It involves logic, which logic is the study of how to make sound arguments, how to use certain principles to derive conclusions. Logic underlies science, physics, chemistry, mathematics, everything. It's engineering. How do we build things? Computers, even if you're just a coder, you might not actually build a computer, but you're relying on somebody else and their knowledge of how electronics works, electronic engineering, to actually make your code work. And then there's also some philosophy involved in terms of what's possible. The reason that we have computers in the first place is somebody a couple hundred years ago had the idea that by putting a few things together, you could actually have a machine that would automatically create answers to questions, right? That's a pretty philosophical thing. It takes a big leap of intuition to make those ideas happen. And there is a lot of philosophy that continually happens around computer science and what's possible. So what are computers? Good question. I feel like we all probably feel like we know the answer to this, right? But here's probably an unexpected answer. They're really dumb machines that are perfectly happy doing the same thing over and over and over. We think of computers as being very intelligent because they do things that we just don't understand how to do, they seem outside of the grasp of our own powers and our own intellect. But they do that by doing very, very simple, repetitious things way more times than a human would even have the patience to do, much less be able to actually carry out. Computers are really fast and really powerful, but at their core, really all they're doing is very, 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 very simple mathematics again and again and again and again and again and again and again. So, just as an example, here's one of the early functions that computers kind of replaced. This is going back to the 19th century. In England, being a sea nation, log tables are very important in the navigating of ships, right? So England, the government, would actually create these giant log tables, these giant books that would allow you to calculate logarithms of various numbers to help you navigate your ships, right? These are a lot of very intense calculations that had to be done more or less by hand. There were hundreds and hundreds of government employees that would just do basic calculations by hand to make these books that the entire government depended on for their national security, right? Fast forward a little bit, this guy named Charles Babbage is widely credited with inventing the first computer, which is basically just a ginormous calculator. That thing right there is what's called the difference engine, and he never actually built it. He designed it. He wrote out the plans out for it, but he never actually got the funding, or the funding was taken away from the government for him to build it. He never built it, but he designed it. He designed the first ever computer, and it's essentially just that thing right there is going to do what your pocket calculator can do, right? But it's built out of hard metal. There's no electronics involved there, no circuitry and that sort of thing involved. That was the first computer, and it allowed them to replace hundreds of government employees that could calculate these log tables with just a machine. Conceptually, at least. They never built it. This does exist, though. You might say they never built it. What is that? That's a replica that they built that sits in one of the National Museums in London. Okay, so here's some applications of just basic stuff that you interact with every day that computing is involved with and software is involved with. Weather prediction is usually done by combining the results of a lot of different computer models. So you have these supercomputers that have different ways of trying to predict what's going to happen tomorrow based on data that you gather today and some mathematical models. And so a meteorologist might run 10 different models and kind of see where the commonalities are and then make that sort of weather prediction based on things like that. Music is used. Any pop music you hear on the radio has a computer behind it, and something that you may have heard of in recent years is something called auto-tune. Auto-tune is where, say, Taylor Swift is singing a song for her next record. She hits that one note that's not quite right or just a little bit off, and they want to fix it without actually changing the rest of her vocal take. They can have a computer and go in and massage that waveform into the right spot. And so auto-tune is used pretty heavily by musicians, pop musicians especially these days. We all pay by credit cards and via e-commerce. Square, PayPal, all of those things are operating on really, really intense software that also happens to need high levels of security as well. And then medical imaging is very computer-driven as well. So I broke my leg recently, and so I got to see a lot of this stuff actually in action and poke around with x-rays within a computer. That was pretty fun. So those are just some of the applications in your daily life that you interact with that involve software. Okay, and art. So this was a better example when this thing was still actually working. There's on your way out, if you look up to the left here by the basketball hoop, there's a set of LED lights that are up on the wall in a grid. And they're not functioning right now, but we built them to actually run off of a microcontroller. So these LED lights, and they kind of function like a big grid of pixels, and the LED lights can light up in different colors, but we can program them. We can program them to be any color we want. We can program them to change colors, to look like a waterfall that you can play Tetris on, anything like that. And so that's an example of what's called digital art. And you can just go Google digital art, and you'll see people doing really, really creative things with software and electronics. So this is actually the code that is running on that thing when it actually works. We're going to skip that piece. So let's talk about how people interact with computers. This is important because programming is one way of interacting with a computer. You all interact with computers every single day, but you're used to doing it, if you're not a programmer, with very specific types of interactions. And so these are probably the three things you use most of the time. The fourth is potentially like a touch. You can use a touch screen. But a keyboard and a mouse, these are traditionally the old school ways of interacting with computers. They allow you to type. They allow you to move the cursor. This is representing Siri or what's the Android version? OK Google or whatever it's called like that. You can interact with the computer there. There's artificial intelligence there that turns whatever you say into some instructions the computer then knows how to react to. But these interactions are things that trigger something within a system by touching a button on a mouse, by typing something on your keyboard. There's software that gets some signal and says, hey, the user just clicked on this part of the screen, or the user just typed, hit an enter key. What am I supposed to do? And software is then supposed to then interpret that and actually make something happen, right? What happens is up to the programmer. So how programmers interact with computers is by coding. So you actually write code as a programmer that can then handle, react to user interactions, that can do things even without a user interaction. You can write automated programs that do things without people explicitly telling them to. So this is just this doesn't really mean anything. This is just like the quickest piece of code I could find to copy and paste when I was making these slides. So there's no meaning here. What is this? This is like a login screen for something that I wrote once. See like password and things like that. Anyway. So programmers, you interact with computers by writing code. You write the instructions that tell the computers how to actually work. So you're the ones controlling the computers as opposed to sort of the other way around. As a user, you only get to do what the computer will allow you to do, right? Which we've all been frustrated with at times. Right? Computers don't think in code, though. So I said that we're going to interact with, as programmers, we're going to interact with computers via code, via things that look like this. These are at least like words, like, it's kind of symbolic, it kind of looks mathy, but these are words that you can read, right? There's else, if, there's a return. These are words that kind of like, once we know what code looks like, these will make sense to us. The computer on its own, a computer by itself does not understand what this means. There's a level of abstraction there. So while as programmers, we're going to interact with computers by writing code, the computer itself on its own doesn't know what to do with that code. And that's because computers think in binary. They use memory and microcontrollers and processors to make calculations that all happen in binary. So we're going to go in a little bit of math here and talk about what is binary. Okay. Does anybody remember what binary is? Binary numbers are? A few of you? Okay. Yeah, they're all ones and zeros. Hold on, I just need to get my iPad here up on the screen. Cool, there we go. So it's a way of representing numbers in ones and zeros. So the number system that we typically use is called decimal. So decimal uses 0 through 9, basically, and different combinations of those numbers to create a number system. Binary is just a way of creating all the same numbers, but only using zeros and ones. So the number 0 in decimal happens to also be the number 0 in binary, because we have 0, right? That's kind of convenient. The number 1 in decimal, if you convert that to binary, happens to be the number 1. That's convenient, too. The number 2 in decimal, well, I don't have a 2 in binary, so how can I write 2 using only zeros and ones? Okay, so think about, let me do a little quick example in decimal to kind of show you how this is going to work. So if I have the number, say, 12, right? And I apologize, I have really bad handwriting, so I do apologize for that in advance. You can think of 12 as 10 plus 2, right? Which you can think of as 1 times 10 to the first plus 2 times 10 to the 0. 10 to the 0 is just 1. Any number to the 0th power is 1. So you can break down any decimal number into things that are sums of powers of 10, right? So I have 1 times 10 to the first and then 2 times 10 to the 0. I can break down any, and you can do this, just pull out 37 and break it down into 3 times 10 to the first plus 7 times 10 to the 0, etc. You can break down any decimal number into this kind of representation. So using that kind of trick, that's how we're going to turn a number into binary using only zeros and ones. Notice that this number and this number are the same as this number and that number. People get that? That's the way this works. That's not an accident. That's why 12 is equal to 1 times 10 to the first plus 2 times 10 to the 0. So if I want to write 2 in binary, I can write 2 as, let's see, I can write it as 2 to the first power, right? And so I can also 1 times 2 to the first plus 0 times 2 to the 0. So I'm just mimicking what I did down here with the decimals. I'm trying to write this number 2 in things that are powers of 2. Just right in the decimal system, I tried to write something that was in powers of 10. Tried to take that number, translate it into something that was a sum of powers of 10. So here, 2 is 1 times 2 to the first, which is just 2. It seems like a silly way to write it, but plus 0 times 2 to the 0. So that means my multipliers here are 0 and 1. So 2 in binary I can write as just 0, 1. Okay? Did we follow that? Thank you. I don't need to write the 0. So, yeah. Do people follow that? Is that okay? So 3 is similarly 1 plus 2, right? Actually, yeah, you do need the 0 here, right? Correct? Yeah, thank you. Okay, got it. Sorry, you don't do this really often in the real world. This is just to explain how this works. Right. So 3 is 1 plus 2, which is 1 times 2 to the first plus 1 times 2 to the 0, right? So I'm running out of space here. But 3 in binary is 11. Okay? So you can use this exercise and you can translate any number. You don't have to take my word for it. You can try it. Any number in decimal, you can translate it to a bunch of 1s and 0s. And 1s and 0s are really powerful in a computer world because it basically means on and off. Think of 1s and 0s as like light bulbs, as a switch. They can be on and off. If this light switch is off, that means 0. If the light switch is on, that means 1. So a computer at its core is a bunch of 1s and 0s that represent binary numbers. And then we have various ways of turning those binary numbers into like letters or words or any other kind of thing that we might want to represent with the computer. But at its core, a computer's memory is a bunch of switches that it represents 0 and 1. And a computer processor, is just multiplying a bunch of 1s and 0s. And that's all it's doing. So when we write code, that's not what the computer is really doing. The computer has to take that code and somehow turn it into a bunch of 1s and 0s, which is a lower level. There are some programmers that work at that level that will write that code that does that, but generally we're not going to. We're going to rely on something somebody else did to take our code, turn it into a bunch of 1s and 0s that the computer can understand, that it can then do its calculations, and then turn that back into an answer. Okay. So the name of this class, Hello World, comes from the canonical example of the first computer program in every language that you learn. So it's kind of a trope. When you learn a new computer programming language, the first thing you do is to say, what's the simplest thing I can do in this language? What's the simplest thing I can do? And programmers since, forever, or the 70s, have always used this canonical example of the very first program you can write in any language, and they call it Hello World because all it does is it prints out a message somewhere, to a screen, to a piece of paper, whatever. It prints out a message to a log file, and the message they usually print out is the message Hello World, as if the computer program is just saying hello to everything else outside of it. So that is the name of this class. That's where it came from, because any computer textbook that you pick up that teaches a new language is going to have an example of a Hello World program. So I'm going to show you a few different examples of these programs that will show you how the same basic function in different languages looks different, okay? So this is Hello World in a language called Java, which is very, very popular. It's used by a lot of big corporations. It's very... a lot of programmers really love it. I think it's pretty fun. And so you need these 5 lines of code to just print something out that says Hello World. Okay, so that's Java. This is a language called C++, and so it kind of is related to Java. You see some similar things. You see some braces and semicolons at the end of this line, parentheses. We saw those back before in Java. I'm just going to go back and show you that again. Man, this is not... There we go. So we see some similarities there. Like there's a semicolon here, there's some braces, there's some parens. So those things are kind of common between these languages, but there's a lot of other stuff that's different. So C++ and Java are from the same family, is what we say. They have like the same kind of like... It's like two different languages that were derived from Latin, as an analogy, okay? So this is Hello World in C++. That'll print Hello World to the screen. This is probably, you're probably thinking, I want to learn this language. Because that makes sense, right? I get it. This is a language called Python, and it was actually written to be as humanly readable and simple as possible while still like doing meaningful stuff. Like if you go online, you can find like languages that people will learn with that are just kind of too kind of dumbed down to really doing anything powerful. Python is built to be very, very simple and readable, but still do powerful things. So Python in today's world is used to build websites. It's used a lot in data sciences, data calculation, numerical analysis, things like that. And it's a relatively new language. When I was in college learning computer science, this is like 2000, Python was like pretty new. People were getting really jazzed about it, and now it's like a legit thing that you can get there are a lot of jobs that will hire you to do Python programming. Back in 2000, it was like a curiosity. It was like, what's this new thing that doesn't have semicolons or parentheses and makes sense? This is PHP. So this is a language, most of the websites that you interact with on the web are written in PHP, including things like Facebook. So Facebook is written in this language. And this will print actually Hello World to a web page. Let's put it out there right on the web page. PHP is kind of ugly. Not many people like it, even the people that use it. But it just shows you a difference. Like you see these question mark tag things, those are totally different than anything else we've seen before. So the same functionality is going to look different in different languages and going to have the same end result. So you might say, why should I learn one language over another? Well, it kind of depends. It's going to depend on the company you're working for, and it's going to depend on what languages you know. If you have an idea for an app and you only know PHP and you going to do it in Python would take way more time than you have. So there are these practical considerations as well. There's some like engineering considerations. Some languages are just built for doing things better. I said Python is really good at data analysis. There's a reason for that. It's not something that we could really go into and understand at this point in our knowledge, but there are some languages that are built for different things. But at the end of the day, most anything can be done in most any language is the lesson. So here's just the definition of a computer program. I don't know why I put that slide in there. So a set of instructions in a given programming language. So I think we're going here. Yeah, here's what's going on. So, sorry. There we go. So what is a computer program? We've talked about, like, we've seen little bits and examples and snippets of different code. We talk about a program all the time, or an app, or a piece of software. What does that really mean? It just means a set of instructions built to do something specific in a specific language. So I can say, make a website for LaunchCode. That is a computer program. That one actually is written in a language called Ruby. I can say, make a new app to, I don't know, share videos with my friends on my iPhone. That is a computer program. I can do something that just like opens up files and pulls out all the instances of the word Edward in the file. That's a computer program. It's something that is atomic, that's a set of instructions built to do a specific purpose. Computer programs can be one line long, they can be billions of lines long, okay? But they all kind of share the same characteristics. So here are those shared characteristics, no matter what language or what computer you're working with. They execute one instruction at a time. Okay, so a computer program can only do one thing at a time. It's not going to do, even when it kind of looks like it might be doing multiple things at once, you'll get to a point in coding where you feel like you're doing writing code that's doing 10 things at once. That's just an illusion. At the processor level of a computer, it's doing one calculation at a time. They also allow you to reuse subsets of instructions. So I can say, write a computer program to make a peanut butter sandwich. And then every day at lunch, I can just run that program instead of having to write the code again and again and again every day. I can write a single set of instructions that can be reused by other people. I can use it throughout my other programs, etc. So that's really convenient as well. We don't have to repeat ourselves very often. Computer programs can make decisions. So as programmers, we're going to write code that might, for example, rely on something that a user types in. All right, we can't predict every single thing that a user is going to type in, and we can't have, 10 billion different ways of handling that user input. But we can say, hey, if the user types in a number and it's bigger than 10, do this. If it's less than 10, do that. We can make decisions based on input or based on the state of the system. If it's raining outside, do this. So computer programs are built to make decisions that we as programmers don't have to make when we're writing the code. We can let that decision happen when the program runs. They can also store data in buckets. We're going to use that word for now. We'll use a different word for that later. They can store data in buckets for use later, and they can use those values without caring about the specific value. So this is the concept of a variable, if you've ever seen code before. So this is the idea that we can say, carve out a little bucket, put a name on it, Chris's bucket, and then I can write code that does something to it, adds 5, capitalizes all the letters in the bucket, whatever, but I don't need to actually care what's in it when I'm writing the code, okay? That's a useful tool as well. And can be made up of many algorithms. So I said a program is a set of instructions built to carry out a single purpose, but those can be pretty complex. An algorithm is really like an atomic set of instructions to solve one specific sort of computational problem, right? So a spell checker would be a computer program that has to look at a lot of different things, right? It might care about when should the first letter of a word be capitalized, when should I care about foreign characters, things like that. Those are all maybe potentially different algorithms that are parts of the same larger computer program. Okay, cool. So here is, this is going to be a demo thing. We're going to take a quick break though, and then come back in like 10 minutes so I can set this up, and we're going to do a demo to illustrate exactly what an algorithm looks like, and also how computers interpret instructions versus humans and make that kind of more explicit. So I've got 2:18, we'll say at 2:28, we'll resume. All right, I think we're going to get started now. Just wait a little bit longer for people to use the restroom. Okay, so any questions so far before we jump into our interactive demo? Going okay? All right. You all stayed after the break, so it wasn't too bad, right? Okay, so we're going to do this fun exercise that just kind of illustrates, as I said before, kind of what an algorithm is, how humans think versus computers, and how that's different to help you start kind of putting these things into your brain and start using them. So I need 3 volunteers, actually 4 volunteers. Let's see. Go ahead and come on up, you. Go for it. And then I need 2 more. Go on up. And then, thanks for raising your hand, Crystal. Come on up. All right. So, one person, we got too many people here. Oh, yeah, okay, cool. So I need one person who wants to write the program, be the computer programmer for making this sandwich. Who wants to do that? All right, come on over to the side here. The other 3 of you get behind one of the sandwiches or sandwich ingredients. So what you're going to do now is just give them step-by-step instructions on how to make a peanut butter sandwich, and then you on the other side, you only do exactly what he says. Okay, make sense? We're going to see how many lines of code it takes to make a peanut butter sandwich. So, and I'm going to write this on the screen as we go. So step 1.
Step 1, pick up the knife. Step 2, put down the knife. Step 3, pick up the peanut butter. Step 4, uncap the peanut butter. Step 4, put the cap down. What number am I?
That's 6.
Step 6, pick up the knife. Step 7, scoop peanut butter with knife. Step 8, put down peanut butter jar. Okay. Step 9, 10. 9. Pick up top bread. Step 10, put peanut butter on one side of bread. Step 11, put bread on bottom bread. Put top bread on bottom bread.
You got it?
Yes.
Cool.
All right.
Those are some interesting looking sandwiches. Thank you all for volunteering. If anybody wants to eat those, those can be your volunteer prizes. Otherwise, you can just leave it there. It's fine. What did we, that was actually, sometimes that goes differently, but what did we learn from that? What's something that you observed about that exercise? He had to be really specific. So even, he was pretty specific. Have you coded before at all, or have you seen this example done before? No? They do this in the CS50 class, and it's usually a mess, because someone's like, oh, put bread on the sandwich, put peanut butter on the bread before they've opened the jar, or something like this. And it's just, computers are very explicit. The whole point is that the reason Crystal's there to be the plant, to only explicitly do what she was told. But he actually did it pretty well. He had it broken down step by step by step by step by step. So they were actually able to make sandwiches pretty effectively. However, even within that explicit breaking down, there were still steps that were maybe a little bit vague, like what was one, put peanut butter on one side of bread. The bread has, 6 sides, technically? So, choose your side. It didn't say which one, so we ended up with a different looking sandwich because the peanut butter is on, the crust. So, and there were some other variations in there as well. So even though he was very explicit, there were still different ways that could be interpreted. With a computer program, then that's going to get you into trouble if you're not explicit. Unexpected things are going to happen. Sometimes you just can't even write something. A program has to be written explicitly. So that's the number one lesson in terms of how we think as people and how a step-by-step algorithm needs to be broken down. So that's an algorithm. That's our first algorithm of the class, how to make a peanut butter sandwich. Okay, so you can take that one home and put it in the kitchen and reuse it again and again and again, just like our functions we're going to write later in the class. So well done, everybody. Thank you. Okay, so just another example of computers being explicit in the difference between English language and computer language. This one I hope it doesn't offend anybody, but it's funny. So the children made delicious snacks. That's precious, right? They also made delicious snacks. Okay, so I don't know. We're driving this point home right now. So back to algorithms. So an algorithm is a step-by-step set of instructions. Algorithms, the algorithm we just saw, let me go back to it, is what I might call a linear algorithm. There's just, step 1, step 2, step 3, step 4, step 5, just a set of things in order. The computer does them one at a time. Bam, peanut butter sandwich. Algorithms don't have to be that simple. They can be more complicated. So here's an example of turning on the lamp. And this one has what you might call branching or decisions within the process. So if the lamp doesn't work, how are we going to figure out what's going on with the lamp? First, you might ask the question, is the lamp plugged in, right? If the lamp is not plugged in, let's plug it in. If the lamp is plugged in, what else might be wrong with it? Is a bulb burned out? If so, replace the bulb. If the bulb is not burned out, so the lamp is plugged in and the bulb is not burned out and it still doesn't work, there's probably something more serious, so we probably just want to buy a lamp, right? So there's two different, what's that? You could try a new outlet. You could try, it could be, maybe you're handy at home electronics and can fix it, maybe whatever. But at that point, I would just buy a new lamp because they're cheap. But the the point is that there's decisions in this algorithm. This is an algorithm, a simplified one of how to turn on a lamp that won't turn on, but there are questions that are being asked, right? And there are different things that happen based on those questions being asked. This is going to look much more like a computer program that you're going to write versus the peanut butter sandwich instructions, which are just top-down linear, okay? We said that one of the aspects of computer programs is that they let us make decisions within the context of the program. This is an example of an algorithm letting us make decisions. Okay, so we're not going to get into actual code today. We're going to do that next time. But what I do want to do is talk about some core concepts, and I want to introduce these. We're going to cover these again and again and again throughout this class. So if you see this and you kind of don't get it right away, don't worry. The whole point is by doing it again and again and again, you will get it. And also, we're going to not spend a lot of time on these concepts. I just wanted this to be a very brief introduction. So if this is overwhelming, if this is a bunch of new stuff and you don't get all of it right away, don't worry. But I do want to introduce some basic ideas and basic concepts that are core to all of computer programming and give us some ways to start thinking about algorithms and start coming up with our own algorithms on our own, which we'll do at the end of the day today as well. So pseudocode is kind of how we do this. It's kind of like coding without actual code. So the idea of pseudocode is that you're still going to take the approach of writing down instructions, and they're still going to be executed one at a time, top to bottom, just like our peanut butter sandwich example was. And we're going to start using kinds of instructions that kind of are similar to what you would actually see in code, rather than just the English language stuff that we saw in our peanut butter sandwich example. So we're going to introduce those code-like constructions. That way we can start using pseudocode, which is going to be kind of like somewhere between like English and actual code. It's going to be somewhere in the middle, but it's going to be using code-like constructs. So two of those are repetition, which we're going to call looping. That's the way we talk about repeating something in code, is that you loop. And we're going to talk about decision-making, which we talk about those in coding as conditionals. If a condition is true or false, we make a different action based on that condition. Okay? And we're going to really hammer pseudocode home next week because it's a really fundamental thing in programming. So here's an example of a conditional. If student at LaunchCode, so that's kind of like Englishy, right? If student at LaunchCode, if you're here, you're a student. If you're at LaunchCode, then you're learning. And if you're not at LaunchCode, you're not learning. This is the only place that you can learn. So that's an if statement. The learn part only happens if you're actually at LaunchCode, okay? You can kind of make any if conditional in a similar way by just saying if something is true, if it's sunny outside, go out and play. If it's raining, get my rain jacket. If it's 8 o'clock in the morning, I'm late to work. But the general format of all of those conditional statements is if something is true, then I'm going to take some action. If it's not, I'm not. And there's another way to do that in kind of what's called if-else, which we'll see next time, where we can say if something is true, do this thing, else do this other thing. But this is just the most basic form of a conditional. We also have the idea of a variable. So when I talked about buckets earlier, I was really talking about variables. So this is a really fundamental concept, too, that is going to be in any programming language you use. A variable is just a named thing that holds a value. Think of it as a bucket, a box, whatever analogy you want. It's something that you can put something in, whether that's a number or a word or a character or anything. And then we can use that named thing, that box, that bucket, that named variable to update it later without actually caring necessarily what's inside of the box. So here's just me creating 2 new variables. Number of burritos equals 2. That's how many burritos I had last week. LaunchCode address, that's a number, right? LaunchCode address is 4811 Delmar Boulevard. That's what we call a string. It's a string of characters. So those are just examples of variables. You can start kind of writing little algorithms where you make a variable and say if I go have a burrito after class, I can say number of burritos equals number of burritos plus 1, and just add 1 to that. Okay, and then there are loops. This is the idea of repeating something. The basic construct of a loop is to do something multiple times, all right? And so there are different types of loops. Here are 2 kind of pretty core types of loops. And again, don't get too muddled up in the details or understanding what each line of this pseudocode is doing, because we're going to hit this hard later. This is just to be a little bit illustrative. The top one is what we call a for loop. You might guess because it has the word for at the beginning. And it's going to do something a specific number of times. There are times when you want to repeat an action a specific number of times. You might know I want to do this thing 100 times. I might want to do it 7 times. That's when you would use a for loop. You don't always know how many times you want to do something, right? So that loop, if I had, instead of n, if I had 8, what would that loop do? Pretty close. Actually, but that little hash thing is just the hash symbol. It's just going to print out 8 hashes is all it's going to do. So on your screen, you would just get 8 hashes in a row. So that's a for loop. It lets us repeat an action that, in this case, a print statement, a specific number of times. A while loop, however, is going to let us be a little bit more flexible with the way we repeat things. It's going to let us keep repeating something as long as a given condition is true, right? So what's an example? Like, while I'm still hungry, take a bite of the sandwich, right? Am I still hungry? Okay, take a bite. Am I still hungry? Take a bite. Am I still hungry? Yes, take a bite. Am I still hungry? No? Okay, don't take another bite. So you're going to keep continuing to do something until that condition fails to be true. So this little example here, there's a lot of different ways that you can write these while loops. This is just meant to be kind of like parallel between the top. These two loops basically do the same thing. They're each going to print out the same number of hashes. The while loop just does it by keeping track of how many we've printed out already and checking if it's less than the number that we put in. So if n was 8, each time we would say, is my variable less than 8? Yes. Okay, print out another hash, and then add 1 to my variable. Is my variable less than 8? Yes. Print out another hash, add 1 to my variable. Once it gets up to 8, once I becomes 8, we add 1 enough times, I will eventually become 8. 8's not less than 8, it'll stop. It'll only run that loop 8 times. Okay? So the main pieces here to think about are to remember for loops do something a specific set of times, a specific number of times. While loops will continue to do an action as long as a given condition is true. They're going to ask a question each time, and if the answer to that question is yes or true, they're going to keep going, otherwise they're going to stop. Okay? So again, don't get too, if that's still a little fuzzy, don't worry about it. We're going to go a lot more, spend a lot more time on these later. So here's something I just want you to spend a few minutes trying to do, and just trying to get into the basic kind of exercise of thinking about writing instructions down, about an algorithm, about step-by-step pseudo coding. So you can do this on your laptop, you can do this on a piece of paper and a pencil, you can do it with your neighbor if you want to. And we're going to do this for like 5 or 10 minutes, see how long people want. And if you feel like you don't really have all the pieces to like just nail this the first time, that's okay. I just want to get you in this exercise of trying to break down problems and trying to think about things in terms of instruction sets and in terms of pseudocode. Okay, so write a set of instructions that prints out all of the numbers between 1 and 100 that are multiples of 7. And you can use, you don't have to use the pseudocode exact stuff that I did up here. Just kind of use it English language as you're thinking about it, as you think about it on the brain. Write a set of instructions one after the other. Okay, there's no like right or wrong pseudocode. Okay, so go ahead and give a stab at that. Well, again, 5 or 10 minutes, and I'll walk around. If you have any questions, I'll answer your questions while you're thinking about that. All right, we're going to move on. Even if you're still thinking about it, that's okay. This is just, like I said, just a chance to get ourselves thinking about algorithms. Let's kind of go through one way you might have done this. Okay, so let me remind myself what we're supposed to do. Set of instructions that prints out all of the numbers between 1 and 100 that are multiples of 7. So we're supposed to print out some stuff, and we're supposed to do it multiple times. What kind of construct, what kind of idea do we have to work with that can help us do something like that? For loop, while loop, you could have used either one, okay? Either one would work. I'm going to do like a for, okay? By the way, the least efficient way to do this, you could have actually, I can write a program that will say print 7, print 14. That's not wrong, right? So in programming, you'll find that there's like never really a one right way to do something specific. There's almost always multiple ways to do it. Sometimes there are better ways and worse ways. This is like not so great. Why is this not a great way to do it? It takes a long time to do it. I have to write a lot more code. There's a lot more chance that I'm going to mess up if I accidentally type 36 or something. I'm going to mess it up. There's a lot more room for error. It's just inefficient. So this is not wrong in the sense of not doing what you're supposed to be doing. It's less effective in the sense of being a good program. Okay, so sometimes programmers will get up on their high horse and say that's wrong. It's not really wrong. It just isn't the best way to do it. Okay, so we said we're going to do this we're going to do it with the for loop. So I'm going to say for, and I want to say, what should my bounds be? My bounds are the times, the counter, or the things that I'm using to loop around. That's keeping track of how many times I've looped. How many times I'm going to loop I need the starting place and I need the ending place. So I'm going to go from 1 to 100. Well, you could do it another way. So yeah, you're not wrong. So here's one way to do it. Here's probably as a programmer, this is the first way I would think of. So that's why we're going to do it this way. And if you have other ways, you can. I'll show you on Piazza later. You can post the different way that you did it, and everybody can kind of see the different ways to approach this. For from 1 to 100, we want to loop, and so I'm just going to kind of be explicit here, and down here I'm going to end loop. And what am I going to do in the middle? Each time around, I have something I need to do, right? What do I need? At this point, I kind of can't really do anything because I don't have a name for this number, right? Let me give it a name. Let me call it I. So I'm going to say I got a variable called I, and it's going to count from 1 to 100. Not just is my loop going to go around each time, but each time I'm going to put that counter into a variable so I can use it, okay? So each time around, I is equal to the number of times that I've gone through the loop. So what do I want to do now? Right, so we want to check something first. How do we check something? What does that sound like? It sounds like, what kind of words? A decision, a condition. What do I have in my pseudocode land? I have if. So I can say if I is a multiple. Now this is pseudocode. If you've seen more code before, you might have done something like I modulo 7 equals 0, whatever. That's cool. We're not there yet. So if I is a multiple of 7, print I. If I is not a multiple of 7, do I need to do anything in this case for this particular? No, that's it. So that's it. That's our algorithm. That will print out every number between 1 and 100 that is a multiple of 7. Does that make sense? Anybody have any questions on that? Again, different ways to do it.
Is there any significance of the 3 dots?
No, I mean, actually, you'll find older programming languages where that does actually, that is what it is. But it's something you see commonly in pseudocode. You can say, you could have done it from, say, I equals 1 to I equals 100. There are different ways to write it. As long as we understand what it's supposed to say in pseudocode, it's fine. Yeah. When you get to actual code, it will matter. You'll have to be very specific. Any other questions? Similar, yeah. So FizzBuzz is a common problem-solving thing that we give to programmers. That one would have you print out words instead of, and checking for 3 and 7 or multiple numbers. But yeah, it's the same kind of concept. Any other questions? You can. Yeah, it depends on, again, pseudocode is, at this point, if I'm saying end loop, I should probably go ahead and use the end if to be explicit about it. So yeah, that's a good thing to do. Cool. All right, let's go back to, let's see where we are. Well, we're getting pretty close to the end. All right, so that is all of the concepts we're going to talk about today. I want to show you another video, which is pretty cool, and then we're going to talk about some of the logistics of the class, where resources are, where the exercises and homework and all that kind of stuff is going to be afterwards. Take care of some business. So this is, just for some context to this video, comes from an article that was in Bloomberg Businessweek last May called What is Code? And so if you just go to Google, if you're interested in the actual article, just Google what is code. It'll be the first thing that came up. It was written by this guy named Paul Ford, And this is like a kind of pretty cool article. I love this article. So I say it was an article in Bloomberg Businessweek, but it actually took up the entire magazine, like cover to cover. It's like a 40,000 word article or something. It's huge. It took me like multiple sittings to finish it. It's also online, and you can read it online. It's pretty cool. It has like, these interactive things in there. This is super long. Don't go home and try to read this. But I would say after, I might like encourage you to kind of like try to read it once we're done with Hello World. But there's a lot of cool stuff in here, a lot of cool ideas, including some ideas we talked about today. But anyway, this video is meant to be kind of a condensed version of some of the main points in that super long article. The guy that wrote it, one of the reasons why it's so good is that the guy that wrote it is not only a programmer, but he's also a writer. So he like kind of gets both of those worlds. And he also owns a business. So it was oriented towards people who work in technology but aren't necessarily programmers. All right, so that concludes the material for class 1. Let's talk a little bit. A couple more points. These are fun points. This is just a context setting thing. If a lot of the stuff that we talked about today was like pretty new and you feel kind of confused, like some things made sense and some things were just totally nonsense, that's cool because that's what it's like to be a programmer. So there's the kind of these two states of, this is a kind of a common programmer joke or variation of it, is that you go back and forth between feeling like you know everything and nothing. Like when you're working on a problem and you solve it, you just feel like you're on top of the world. Like you can do anything, like you just hit a hole in one or whatever sports analogy you want to make. But until you solve the problem, you feel really stupid and helpless and like you're totally lost. It's kind of like a binary thing. So if something doesn't make sense at any point in this class, don't get discouraged. Just keep thinking about it. Ask questions. Keep trying. If you think about code enough, you'll start thinking about it like while you're eating dinner, while you're sleeping, while you're going for a run. And sometimes that's when things actually start to make sense for you. I'm not making that up. I've woken up and solved problems, having solved problems to code in my sleep. But anyway, don't get discouraged because it's hard. It's supposed to be hard. It's also fun. And so now we're going to talk about some resources that we're going to use for the class. Okay, so all of this stuff is going to be available to you. The main thing is, did anybody? Well, so I just sent it out today, so you might not have checked your email today. But if you did not get a Piazza invite link in your email, be sure to email me today or tomorrow. Just send me an email, chris@launchcode.org. Everybody should have received an email invite to join Piazza for the class in your email this morning. So Piazza is just like a communication question and answer kind of platform that we're going to use for communicating. We're going to prefer Piazza over email or anything else. And it's also going to be like the place you go when you forget what the link to the course webpage is or things like that. So that said, the course webpage is education.launchcode.org/hello world. I've got it pulled up right here. Here's a quick tour. It's going to be pretty simple. This isn't a complicated class. The first page is just kind of like, what is this stuff here? What's the class about? And then there's the Piazza link, so if you forget that, it's there. There's also the calendar. So the calendar is going to be where most of the stuff that you're going to want to look at is. It's just a day-by-day overview of what we do in each class along with the resources. So the first class, it's today. Today's the 5th. Before class, there was nothing for you to do before class. During class, there's class 1. I'm going to start adding the notes from the class along with slides from each one. And basically as much content from these lectures and presentations as I can, I will put up here. Not everything is going to translate well. I'm recording today's lecture in audio and video. If those come out well, I'll put those up here. Whatever. I'll try to put up as much stuff up there. People learn in different ways. Some people want to read stuff. Some people want to listen to it. Again, I'll put up as much stuff as I can up there, including just kind of like a rough like notes. Here's what we did. Here's this idea we talked about. Here's another example. Here's a link to this video I showed you. Things like that. So that's all going to go here. And then for next time, there's a high-level summary of what we're going to do. So next time we're going to dive deeply into pseudocode and really think hard about some problems. And then we're also going to look at our first programming language, which is JavaScript. And that's what we're going to be doing through the rest of the class, is learning some basic JavaScript. So the prep work is to, you don't have to feel obligated to do all of this. Do as much as you have time for and do as much as you can. But these are all videos that are going to kind of set the groundwork for the concepts we're talking about next time. And these come from different places. This first one comes from CS50, the very beginning of that class. This is another CS50 video. Some of these come from other places on the web, Viking Code School, which is just like a free site to learn coding stuff. So these all have different, different takes on the same types of topics. If you find one that you really like more than others, post about it in Piazza or tell me or whatever. But again, don't feel like you have to do every single one of these. Do as many as you can. Don't feel like you shouldn't do them. Don't feel like, I'm just going to come in and wing it and it'll be cool. Spend some time thinking about these things before you come into class. That way you're really going to maximize your learning, okay? So there's the prep section, and then in class again, that'll just have what we do in class too. And there will also be some exercises in a site that will be linked up here that is as yet finished, some JavaScript exercises that we're going to do as homework from class to class, and I'll have the first set of those up for next week's class. So that's what is going to kind of keep you on top of what we're doing. Let's go to Piazza real quick. This is going to look a little different for you than it does for me because I'm an instructor. But I told you your first homework assignment is to go into Piazza and answer this poll. So on the left-hand side of Piazza, you see questions that people are asking. You can look at questions based on different topics. Each question can go into a folder. And okay, so this is just a poll, and so I put up a poll here. Why are you here? Why are you taking this class? So just go ahead, just to get yourself in Piazza, make sure you can log in and get yourself kind of a little bit familiar with the interface. After class, go in and answer it. 38 of you already, more than 38. 68, that's pretty good. 68 of you already went in and did that, so that's cool. You're done with the homework. If you haven't done that, go do it. And again, if you did not get an invite to Piazza, email me within the next day or so. So this is cool. So it says, so far, 54% of you are interested in a career in programming. That's great. A few of you are just interested as a hobby. And some of you just kind of don't know. You're just curious, right? And then other. So 3 people are here for other reasons. Kind of cool. You can also, if you have a question about anything, you can go in and ask that question. So somebody asked, this is before class today, do I need to bring my laptop to class 1? In general, yes. Today, though, as you saw, we didn't absolutely need them. So the way this works is I can answer your question, or another instructor. Crystal and Zach and a couple of LaunchCode people are in here to answer questions. Our students you also answer each other's questions. So this is way better than email because sometimes, like there's however many hundred of you out there, it can be quicker to answer your peers' question than I can be to get back to them. It also just kind of helps build this dynamic of helping each other out. So for every single question in there, it'll tell you if the instructor answered. You get the little I next to it. And I can comment on other people's questions. I can edit things, whatever. But in general, this is just a great way to help each other out. So feel free to ask questions. You can ask questions anonymously, so it won't have your name on it. So if you feel like it's a silly question, just put it up there. Nobody will know it's you. It's cool. And then they can get answered by me or another student. And so it'll just a good way to have everything in the same place. So if you have a question, see if somebody else asked it here first. Okay? That's also going to be way more efficient than me having to answer the same question 10 times via email. So we're going to use Piazza for that. There's also, if you go to the resources, this is just kind of high-level overview stuff. I'm not going to use these things as much because those are kind of on the course site. But like I said here's a link to the course website. Here's a link to the course staff email. If you need to email us, you can. We're not going to tell you not to email us, but try to have your questions answered via Piazza and just general information. So class times, again, four Saturdays throughout the month. We're also going to start doing Monday meetups. Once we have homework to work on, we're going to start meeting on Monday. And these are totally optional. Just want to give you another chance to kind of work together to get answers from me and other volunteer mentors on the code you're working on. Since we don't really have any coding homework this week, we're going to start those the week after, and those are going to go 5:30 to 7:30 on Mondays here. And those will continue after the class, as I mentioned before. The goal for a lot of people in this class is to get to CS50. CS50 is running right now. It won't start again until the fall because it's a 16-week class. It takes a lot of energy to build it up. So we don't want you to just send you home and have you do nothing for 4 months. We want to give you something to do and to keep learning and to keep gaining skills as a programmer. So we're going to have weekly meetups where there will be learning tracks you can work through and keep learning until CS50 is ready to go, and then you'll be on top of it, and you'll be able to kick butt in CS50 in the fall. And I'll put announcements up here as well, and you'll get notified of these via email usually too. So that's kind of the lay of the land. Go into Piazza. If you didn't get a Piazza link in your email me, and we'll get that all sorted. But otherwise, that's kind of how the class is going to work. Any questions about the logistics of the class or how things are going to operate here? No grades, obviously, nothing like that. This is all, if you want to learn it, you should learn it. I'm not going to keep you accountable. It's a free class. The whole point here is to just give you exposure and an opportunity. So there's no classes between. There there might be a summer class, actually, like a CS50 kind of class in the summer. We don't know about that. That's in the works. So there's a possibility that you wouldn't, if you were interested in taking CS50, you could take something like it in the summer. But the next version of CS50 isn't starting until September. So weekly meetups on Mondays, we're going to do those. And so those will be open to anybody that took this class and just the general public. You'll be able to come in, and there'll be learning tracks that'll be more or less self-guided, but you can get help with from other students or mentors as you work on those learning tracks. Just kind of a meetup style rather than a class. Yeah. So there's here's all the things that LaunchCode does in terms of education. There's Coder Girl, which is a meetup on Wednesdays. That's open to anybody. As Crystal said, it's designed by women. That doesn't mean it's exclusive to women. It just means that it's a very welcoming, friendly, open place for people to learn. So men can come. There are male mentors and students there. That's every Wednesday. And again, that is more of a meetup style rather than the class. We also have classes, adult classes with Blue 1647, which is an educational partner. There'll be signups for the next round of those classes starting in late April. And those are based on web programming. Those signups will go up probably this week. So once those are up, I'll send a note out to everybody in this class about that. Cool. Any other questions? Awesome. Thank you so much. This is really fun. Looking forward to seeing you every Saturday in March. And yeah, enjoy the rest of your Saturday. It's nice out there.